I spent a year in Iceland in the U.S. Navy hunting Soviet submarines. I was doing this for Washington, D.C. Washington was mostly interested in the K-19 boat, the first Soviet sub with SLBMs, submarine-launched ballistic missiles. The sub was a rush job, carried 3 missiles in its sail. They were liquid-fueled. The handling of propellant in a hull that also had 2 nuclear reactors made the K-19 a dangerous boat for the crew. They nicknamed it Hiroshima. Sailors thought it would have bad luck because of a clumsy christening. The boat itself somehow survived the Cold War, but a dozen of its crew did not. I didn't know or imagine the young Russian, someone my age, 20 years or so, who found himself under the surface of the Atlantic. He might have been the radio operator. He might have been the one who sent a quick burst of a signal to the Northern Fleet headquarters in Murmansk or Archangel. I bet they'd been told in training that it would be impossible for the U.S. Navy to intercept and direction find that signal. It wasn't easy, but with enough money thrown at the problem, it was done in the early 60s. Using the principle of brute force, they managed it. The postulate was that an infinite number of monkeys at an infinite number of typewriters would in time randomly come up with one of Shakespeare's plays. The NSA or NSG used humans, not monkeys, maybe 50 at 50 receivers, each receiver with a tape recorder. Like a search party sweeping a field, walking in a broad line, each only a few feet from the other, so as to miss nothing. The receivers were tuned a few kilohertz apart. The range of frequencies chosen were those best for sending a signal from the mid-Atlantic to northern Russia. The ionosphere decided this. Where in that wide range on the high-frequency band was our problem, determining where. The Soviets knew. They had a plan called the frequency rotor, a list of times and exact frequencies chosen in advance. The National Security Agency had an idea of the signal they were looking for, a short burst, less than a second, a series of ones and zeros, a signal the casual listener could easily mistake for static. With patience, they captured a few of these bursts on tape. Then they taught a computer to do the listening, to look for that signal and ignore all else. It worked and was refined and sent out into the field. The same antenna used to track ships would feed this computer with earphones. It would give an alarm when it heard the burst. That alarm contained the frequency and time. Meanwhile, in the section I worked in, 2 giant data recorders were storing wide chunks of the high-frequency spectrum. Next to each receiver, next to each bank of receivers stood a cabinet with nearly 100 large magnetic tape reels. Every 15 minutes, I'd change the reel. I'd also clean the recording heads. The chemical I used was carbon tetrachloride. It removed any buildup of oxide from the tape. It might also have killed a few of my brain cells. I'd replaced it with the tape from 24 hours prior. The tapes, in addition to wideband spectrum, had direction-finding information. A goniometer electronically rotated the antenna 360 degrees every few seconds, several times a second. When a signal was detected, generating an alarm, I located the tape in the cabinet. I mounted it on a playback deck above a receiver, which I tuned to the alarm frequency. I set the tape to a few seconds before the indicated time, and like magic, there it was, a burst that sounded for all the world like a fart. The huge circular scope presented the outline of a butterfly with one wing larger than the other. I positioned the cursor on the scope to the tip of the larger wing. That was the bearing. That was the number I sent to Washington. With bearings from a dozen other stations, the sub's position was fixed. We knew nothing of one another, but that young submariner and I were linked by that little burst of radio waves. I wonder if he's still alive, old but alive, and Mother Russia.